Hello everyone. Let's look at these multiple choice questions. 1.1. Two forces of 3 newtons and 9 newtons act on the same point. If the angle between the forces can have any value, which one of the following cannot be a possible magnitude of the resultant force? So it's important for us to remember here that we will get a maximum resultant when the two forces act in the same direction. So in this case, if we had the force 3 Newton here and 9 Newton there, the resultant would be 3 plus 9, which is 12 Newtons. And also, we will get a minimum resultant when they act in the opposite direction. So, for example, you can have the 9 Newton pointing to the right and the 3 Newton pointing to the left. In this case, the resultant will be 9 minus 3, which is 6 Newtons. So these two values are very important because they tell us the boundary, if you will. So we'll have a maximum value of 12 Newton. We'll have a minimum value of 6 Newtons. And anything in between is also possible. Anything in between is possible. So D is possible. 7.5 is possible. 12 is possible. What's not possible is 13. So A is the correct answer because it's not a possible magnitude of the resultant force. Okay, next question. Two forces act at a point as indicated. If the angle theta is decreased from 120 degrees to 0, the magnitude of the resultant force will what? Okay, so again, related to the previous one, if you have the forces like it's drawn in the diagram, and now you draw them pointing in the same direction, you are getting closer to the maximum. You are getting closer to the maximum. Closer to the maximum, which means that the resultant force will increase. However, if you were going in the opposite direction, then you're getting closer to the minimum, and then the resultant would decrease. But just to answer this question, the magnitude of the resultant force will increase. Okay, and the last one, 4 tugboats apply forces to an oil rig as shown. Which of the following vector diagrams represent the magnitude of the resultant? So in this case, I don't have the different options, but we will just draw in the resultant. So what we need to do here is we need to draw, or we need to add or subtract the forces here. So here we have 40 kN, which stands for 40 kilonewtons, then 50 kN, 50 kilonewtons, 40 kN, and then 30 kN. Now, if you think about it, you have 50 kN or 50 kilonewtons pulling to the left, and you have 40 pulling to the right. That means you're going to have a resultant of 10 kilonewtons to the left. How can you do that? You can think of it like this. The resultant in the x direction would be 50 minus 40, and that's 10 kilonewtons to the left, right? Since they're pointing in opposite directions. And if you want to do the resultant in the up and down direction, the resultant in the y direction, or up and down, vertical, whatever you want to call it, that would be 40 minus 30, and that would be 10 kilonewton upward. So if we were to draw these in, we have a resultant in the horizontal direction to the left, like so. And then we have a resultant in the vertical direction pointing up. And so if we wanted to work out the resultant of these two, it's quite simple, because then the resultant will always be in the quadrant between them. So my resultant will be pointing in this direction.